Welcome to HSC Math. I'm Joy Song and I will be going over polynomials. From the literal definition to how to factor polynomials, I will be covering the basics of polynomials in two parts. This is part 1, Polynomials Overview, simplifying polynomials, and adding and subtracting polynomials. So, what exactly is a polynomial? Well, when the word is broken down, we can see that there are two parts, poly and nomial. To start, the root poly is the Greek root word for many. Think about the word polygon, a 2D shape with many sides and many angles, like this pentagon. This pentagon has 5 sides and 5 angles. Another word with the root poly in it is polytheistic, which means to worship many gods. For example, the polytheistic Greeks worshiped the Greek gods and goddesses, some of them being Zeus, Poseidon, Athena, and Ares. The other part of the word, nomial, comes from the Latin root num for number. This is easier to remember because nomial sounds pretty similar to number or numeral. So now you know what the word polynomial really means. It literally means many numbers. But what exactly is in a polynomial? Let's first review what a term is. A term is a single number or variable, or numbers and variables multiplied together. So 7 is a term. X is also a term. 31y, a number multiplied by the variable y, is another term. There can even be more complicated terms, like 3 times x squared times y squared. So a polynomial is a combination of many terms. This means that these terms are connected through operations. Polynomials can also have different names. For example, a monomial, which contains the root mono, meaning one, is a polynomial with one term. A binomial, which contains the root bi for 2, is a polynomial with 2 terms. A trinomial, which has the root tri, meaning 3, is a polynomial with, you guessed it, 3 terms. Any polynomial with more than 3 terms is usually just referred to as polynomials. Here are some examples of polynomials. This is the polynomial 3x plus 9. The terms in this polynomial are 3x and 9. They're connected with an addition symbol. This indicates that these two terms are being added together. This is another example of a polynomial, 4y squared minus 3x. The first term, 4y squared, includes the number 4 multiplied by y squared. The second term, 3x, contains the number 3 multiplied by the variable x. 3x is being subtracted from the term 4y squared. Now that you have a basic understanding of what polynomials are, we can learn how to simplify polynomials. Simplifying polynomials is very similar to combining like terms. If the variables are similar, they can be combined. 4x and 8x can be simplified because they both have the variable x raised to the first degree. If we add these together, it would equal 12x. For polynomials to be simplified, they must also have the same degree. 9y squared plus 14y squared minus 2y squared can be simplified because all of the terms include the variable y raised to the second power. If one of these terms were raised to the third power, it would not be able to be simplified with the other two terms. Now, let's try simplifying some polynomials together. This is the polynomial 4x plus 8x. We can see that these are like terms because both of the terms have x raised to the first degree. To combine these terms, you would add their coefficients, in this case 4 and 8 together. When this polynomial is simplified, it becomes 12x. Let's try something a little more difficult, 3y plus 12y minus 7z. The idea is the same. Add the coefficients of the terms with the same variable and degree. In this case, it would be 3y and 12y. Negative 7z can't be combined with 3y and 12y because it contains the variable z. So 3y would be added to 12y to create 15y, and negative 7z would remain to make the final simplified polynomial 15y minus 7z. This one's a little bit more difficult, but I would like you to try and pause and figure it out on your own. So in this polynomial, there are two different pairs of like terms. The first one is 8a squared and negative 4a squared, which simplifies to 4a squared. The other pair is negative 2b and 3b, which then just becomes b. When we combine these two, we will get the polynomial 4a squared plus b. Now that you've learned how to simplify polynomials, adding and subtracting them will be relatively simple because they are very similar. All you have to do is to remember to group and combine like terms, and that the operations will remain the same. Here is an example. We can ignore the parentheses because this is adding polynomials, so the operations will remain the same. Now we can see that there are three pairs of like terms, 7x squared and 2x squared, 3y and negative 6y, and 3 and negative 2. Pause the video now if you would like to figure this example out by yourself. First, combine 7x squared and 2x squared. This will equal 9x squared. Next, you can simplify 3y minus 6y, which will equal negative 3y. And finally, when you simplify 3 and negative 2, you will end up with 1. The final polynomial will be 9x squared minus 3y plus 1. You know that you can't simplify this polynomial further because there are no like terms. Let's take a look at another example. In parentheses, 3b cubed minus 6a plus 9c plus, in parentheses, 4b cubed minus 8a minus 2c. Again, if you would like to solve this one on your own, please feel free to pause the video. To start, you can release the parentheses and pair up the like terms. 3b cubed and 4b cubed are like terms because they both have the variable b raised to the power of 3. When combined, this becomes 7b cubed. The next pair of terms are negative 6a and 8a and negative 8a. When they are combined, they result to negative 14a. The last two terms remaining are 9c and negative 2c. Once these are simplified, it becomes 7c. So the final answer will be 7b cubed minus 14a plus 7c. Finally, we will be learning how to subtract polynomials. Subtracting polynomials is very similar to adding polynomials, except you need to pay a little more attention when you are releasing the parentheses. Let me show you what I mean. This polynomial is 5j squared plus 19k plus 1 minus negative 13j squared plus 4k minus 2. But when we release the parentheses, it becomes 5j squared plus 19k plus 1 plus 13j squared minus 4k and plus 2. Notice how the second expression signs became the opposite when we released the parentheses. This is because of the negative symbol, or negative 1, that was initially in front of the expression was distributed to every term. Try solving this one on your own. First, you take 5j squared plus 13j squared, which creates 18j squared. The second term we need to simplify is 19k minus 4k, which becomes 15k. Finally, 1 plus 2, that's 3. Your final answer should be 18j squared plus 15k plus 3. Let's just try one more. Again, if you can, pause and try to solve this one on your own. First, let's take the initial expression, 19x cubed minus 2z minus 7 minus 9x cubed minus 8z plus 3, and release the parentheses. 19x cubed minus 2z minus 7 minus 9x cubed plus 8z minus 3. Now combine like terms. 19x cubed minus 9x cubed is 10x cubed. Negative 2z plus 8z is 6z. And negative 7 minus 3 is negative 10. The final answer should be 10x cubed plus 6z minus 10. Let's review what we've learned. A polynomial is a combination of many terms. You can remember this by thinking about the Greek statues we saw throughout the video. The Greeks were polytheistic, or worshipped many gods. A term is a singular number or variable. If the variable and degree is similar, they can be combined. For example, 4x plus 8x is 12x because you add the coefficients. Adding polynomials is basically like simplifying polynomials, but you have to release the parentheses. Subtracting polynomials is very similar to adding polynomials, except that you need to remember that the second expression signs will be the opposite because of the negative 1 being distributed to every term. Thank you so much for staying to learn about polynomials. Come back in part 2 to learn how to multiply, divide, and factor polynomials. See you next time!